Alright, this is our notes number 2 in geometry. It's titled Use Segments and Congruency, section 1.2. Make sure you put your name, the date, and your class period. Your essential question is explain what congruent segments are. So you know your essential question. Alright, on this section here, let me zoom in a little bit so that you can see it. Let me get the light shifted. Ooh, that's orange. It says in geometry, and that's too light. So it accepts the rules without proof is called a postulate. So that's very, very important to understand what a postulate is. It's just a rule that it's accepted to be true without any kind of proof whatsoever. And here is postulate number 1. So this is our very first rule postulate. So let me zoom out just a little bit so I can turn the light back on. And it says that points on number line that match 1 to 1 on the real number line, then the real number that corresponds to the points on the coordinate of the point. So the distance between A and B is written as the AB. That's important to know that when you write for the distance, it'd be just the letters AB together. They do know it's the absolute value, so that means it's always going to be a positive value, is what this is understanding here. It'll always be positive distance. You'll never have a negative distance when it's asking for the length of something. And on postulate 2, this is very, very important. That's why I have it marked over on the side. This is something that students have trouble remembering for the whole lifehood of geometry, is this very, very bottom statement. And basically the segment addition postulate is you take two segments, add them together, and they equal the long segment. And in this setup here it says AB plus BC equals AC. To give you a little picture over on the side, if I have a segment that has endpoints and then a value inside, as AB plus BC, B's in both sections. That means B must be in the center or between the two endpoints. So I need an A, a B, and a C. So it's saying if I look at AB plus BC, that distance, it should equal the entire length, which is from A to C. Which hopefully that kind of makes sense when you think about lining things up and count how long they are. Also, this last statement here, it says line segments that have the same length are called congruent segments. So if they're exactly the same measurement, we're going to say that they are actually congruent segments. And our congruent symbol, by the way, is going to be the equals with the little squiggly line on top of it. Will be our congruent symbol for segments. Alright, example number 1, we're looking to find the length of BC. If I look at the picture on the side, BC is this mystery that's here on my picture. Notice it tells me AB is 10 and the entire length all the way across is 32. So if I use my segment addition postulate, it tells me that if I take A to B plus B to C, it should equal A all the way to C. And if I substitute the values into it, AB is 10 plus BC is my X, and AC is 32. Here I have an algebraic equation where I just need to subtract 10, and that tells me that my X is going to equal 22, which also means BC, for the correct notation, is 22. Okay, if I look at example 2, it says the locations shown lie on a straight line. So if I look over to the side, I have it very, very small. Realize this is not needed. That was extra in the picture. So ignore that little value. If I zoom in a little bit, so I can see it on the overhead, it says find the distance from the starting point to the destination. So the starting point is S, and the destination is D. And notice I have the first section, which is SR, is going to be 64. I want to add to it the second section, that is RD, which is 87, and it should equal the entire distance, which is from S to D. So all I have to do is add these values up, and I'll end up with 151 miles. So SD is equal to 151 miles from the starting point to the destination. This is still using segment addition postulate, but you did not have to work backwards like you did on example 1 where we had to subtract. This one was straightforward, and we just added our two small segments and they equaled the large segment. Alright, on example 3, we're going to be comparing segments to see if they are congruent. On number 3, I have to plot the 4 points. Alright, right here, I believe that is a typo on mine. I will fix that on yours. I believe that's just supposed to be -4, not -14, because I can't plot that on my graph at all. So that's going to be my G value. So I have a segment that goes from F to G. It is a horizontal segment. And then I also have here is H and J. Okay, I have plotted my two segments, and it says, okay, then determine whether FG and HJ are congruent to each other. So since I have a horizontal line, I can actually just count the length. 1, 2, 3, 4, 5, 6, 7, 8. This is 8 units long. And then HJ is a vertical line, so I can actually count this line as well. 3, 4, 5. I see that this one is 5 units long. And can I say that they are congruent? Well, to be congruent means their lengths have to be exactly the same, and since one's 8 and one's 5, FG, I'm going to put is not congruent to HJ, and I got to put the symbol for segments when I use the congruence. Okay, when I set things congruent to each other, it is not setting them equal to numbers, it is setting them equal to geometric shapes, or congruent to geometric shapes. Alright, independent problems. You have one down here on the bottom of the page, but it has two parts. I want you to find QS, so I want you to find the distance all the way across, as well as PQ, which is this little piece on the end. Find those measurements. When you have it, make sure you answer your summary. Remember, your summary is answering what are congruent segments. Raise your hand and I'll tell you what your assignment is.